Okay, so as in the last video we have solved the numericals. We have basically calculated what we have calculated basically is the mass, and in the second question we calculated volume, right? And we know the basic steps, right? How we're gonna calculate the volume or the mass if there are moles given in the question, or if they have asked us to calculate the moles, then they must have given the volume or the mass in the question, right? And we have applied our mole concept on the chemical equation. Now we know how to calculate the number of moles, either the number of moles or the volume or the mass, by the chemical equation, by the balanced chemical equation, because we know that what was the first step. The first step was to balance the chemical equation, then we were supposed to start, right? So initially we balanced the chemical equation, and afterwards we calculated the required value which was asked in the question, right? So in today's video we are going to start our second topic, which is about the percentage composition, right? So today we are going to start percentage composition, right? Percentage composition. It will gonna let us know how much percent of any element or of any molecule is present in the substance, right? For example, if I have a H2O, right? If I have H2O, I need to calculate the percentage of this oxygen in the H2O molecule, right? Percentage of this molecule or substance, right? So I need to calculate the percentage of oxygen which is present in the water molecule, right? Then how I'm going to calculate it? So basically we have a simple formula, right? So percentage composition is basically equal to the mass of that quantity in the compound. For example, if I am going to calculate the hydrogen percentage in the water molecule, then I need to take out the mass of that quantity in the compound, means mass of this O2 in the compound, right? I'll be taking the mass of it, right? So let me write here mass of that quantity in the compound, quantity in the compound or in the substance, right? Let me write here compound, divided by what I'm gonna divide it by. I'm gonna divide it by the mass of this entire substance. I'm gonna divide this by the mass of the entire substance, right? So upon mass of that quantity in the compound and the mass of the compound, right? Mass of the compound. And of course, if you are going to find the percentage of it, you need to multiply it by the 100, right? Multiply by 100, right? This will gonna give you the percentage composition, means how much percent of that particular quantity is present in the compound or in the substance, right? How you're gonna calculate that? You're gonna divide the mass of that particular quantity which you are going to find the percentage of in the compound. You're gonna divide it by the mass of that entire compound, and of course if you'll be finding the percentage of it, you need to multiply it by the 100, right? Then you're gonna get the percentage of it. Now basically I'm calculating what? I'm calculating the percentage of oxygen in water molecule, right? So let's find percentage of oxygen in H2O, right? Percentage of O2, matlab how much oxygen or how much percentage of oxygen is present in the H2O molecule, right? So let me highlight this first. Now just put this formula, right? Use this formula. We have initially need to write the mass of that quantity. What we are finding the percentage of, we are finding the percentage of the oxygen, right? So oxygen, now see the oxygen, how many atoms of oxygen are there in the water molecule? There are only one atom of oxygen. Means what is the mass of the oxygen here? Here the mass of the oxygen is 16 gram, right? Upon, we need to divide this mass of the particular quantity by the mass of the entire compound. Now we know that what is the mass of the H2O. Basically we have two hydrogen atoms, 2 plus, and one atom of oxygen has a mass of 16 grams, so 16 plus, right? And we're going to give us 18 gram. So the mass of the H2O is 18 gram. Basically what we have done here, we have taken the mass of only an element which we were going to find the percentage of, and that was of course oxygen, and we have taken the mass of the oxygen, and of course we know that that is 16, right? And that we need to divide by the mass of the entire compound. We have H2O and the mass of the H2O is 18, so we have divided 16 by 18 gram. Of course we are finding the percentage, that's why we need to multiply this by the 100, right? So now see, 9s are 2 9s are and 2 8s are, right? 8 upon 9 into 100, and this will gonna give nearly to you percentage composition. Wait, let me write here. Of oxygen is 88.88%. Means how much oxygen is present in the H2O molecule? There is basically 88.88 percentage present in the H2O molecule. Means how much percent of hydrogen is present now? Means hydrogen would be present, must be 12.222, right? So that would be the not 12.2, however 11.22, right? And when we combine these both, we're gonna get 100, right? So basically how much percentage of oxygen is present in the H2O or water molecule? We have 88.88% of oxygen present in the water molecule, right? Now we have another question. We'll wind this up very quickly, and we need to have a grip on this as well. That's why we are just going to solve another question as well. Now we need to find the percentage composition of H2O, the entire compound H2O, right? In magnesium sulfate, 7 molecules of H2O. Means how much water molecules are present in this entire compound. How much water molecules are present, or how much percentage of water molecules are present in the entire this compound magnesium sulfate and 7 molecules of water, right? So we know the formula. We need to take the mass of the particular quantity which we are going to find the percentage of. So here basically the mass of the H2O is 18, and basically we have here 7, the molecules of H2O. So we need to multiply this mass of 18, mass of water, into 7, since we have 7 molecules of water. So it will gonna give us 126, right? 126 means I need to take the mass of the 7 molecules of water as 126. So we have taken the mass of the particular quantity which we are going to find the percentage of, and that is of course 126. So mass we got here is 126. Now we need to take the mass of this entire compound, right? So we know that the mass of the magnesium is what? It is basically 24, right? Then the mass of the sulfur is 32, The mass of oxygen is 16, but there are 4 atoms of oxygen, so 16 into 4 is 64, right? Plus the mass of the 7 molecules of water, and that we have calculated, so plus 126. It will gonna give us basically 239, right? So we need to divide this 126 by what? By 239, which is the mass of this entire compound, right? So we were going to find the percentage composition of H2O molecule which were present in the magnesium sulfate and 7 molecules of water. So we have taken the mass of that particular quantity which we were going to find the percentage of, and that was water. There were 7 molecules of water, so we have taken the mass of the 7 molecules of water, and that is equal to 126. Now we need to divide that particular mass by the mass of entire compound, and here the mass of the entire compound we have got as 239 gram. Now we are of course finding the mass or the percentage of it, so we need to multiply it by the 100%, right? When I'll solve this, I'm going to get the percentage composition of H2O in magnesium sulfate and 7 molecules of H2O as how much? 52.71%, and the rest would be magnesium sulfate, right? If 52.71 percentage of water is present in the magnesium sulfate and 7 molecules of water, then there must be rest of the amount would be present of magnesium sulfate in the substance, right? So here we have got a percentage composition of 7 molecules of water in the magnesium sulfate and 7 molecules of water as well, and that is equal to 52.71%, right? So today we have covered a very important topic, right? And that was related to the percentage composition. Means you can find the percentage of any element which is present in the compound. So this was all for today. In the next video, we'll be studying about molecular formula and empirical formula.